Hi, welcome to my video on discontinuity, extra problems. First problem is write the f of x as a piecewise function so that it is continuous at x equals 1. So let's look at the f of 1 to see what we have. And we have, put it 1 in place of x, we have 1 cubed is 1, 1 minus 1 is 0. And we have 1 in the place of x, so 1 minus 1 is 0. So at 1 we have a what we call a indeterminate form, 0 over 0. So that means we'll have to eliminate, because it's at 1, so if you put 1 in, you get 0 on the bottom, we can't have it. So because it's 0 over 0, we have an indeterminate form, so that means we have to see if we can remove the x minus 1. What we have on the top is we have x cubed minus 1x, so x cubed minus 1x is the same as x cubed minus 1 cubed. So that's the difference of two cubes. And the difference of two cubes is a cubed minus b cubed is factored. I didn't mean to put the brackets there. A cubed minus b cubed is factored as a minus b times a squared plus ab plus b squared. So we have a and b. So we have cubes. So that means a is x and b is 1. So if we sub that in here, so we have x cubed minus 1 cubed is the same as a is x. I better be careful now. A is x, so I have a minus b, so it's x minus 1. A squared is x squared. A times b is 1 times x is x. And b is 1, and 1 squared is 1. So that's the factorization. That means the f of x is factored as x minus 1 times x squared plus x plus 1 all over x minus 1. So that means that's simplified to the x minus 1's cancel out, and I get x squared plus x plus 1. So when I put, notice now that the x minus 1's cancel out, we removed it. So if we do the f of 1, we get 1 squared plus 1 plus 1. So that's 1 plus 1 plus 1. That gives us 3. So that means we have a point, which is 1 comma 3. And that point is, the point is a hole. It's removed, but it's still a hole in the graph of the f of x. So to write it as a piecewise function, so we go f of x is equal to, so we have f of x is x squared plus x plus 1 when x is not 1. When x is not 1, this is the function that we have here when we removed it. And also, we have a 3, so it's 3 when x is equal to 1. So now we've created a continuous function at x equals 1, because it's defined at 3, and it's the right limit and the left limit become 3 also. So we have a continuous function with a hole in it. It was a hole in it because we removed x minus 1, but when we write as a piecewise function and let x equals 1, the hole is filled in. Okay, let's look at another one. The f of x equals 5x minus 20 over x squared minus 2x minus 8. So let's look at factoring this to see what happens. That's 5 outside of x minus 4. And we have a quadratic. Hopefully that quadratic is factorable nicely. So x squared is x and x. Factors of 8 to give me a 2 is 4 and 2. And it's a negative 4 plus 2. And you notice that it's the x minus 4 cancels out. True. But before we do that, we're looking at the 4 cancels out. So that means this simplifies to 5 over x minus 2. But before we do that, let's look at x minus 4. Let's look at the h of 4. Let's see what happens to the h of 4. We're putting 4 back into this expression. And we get 4 squared 2 times 4 minus 8. There's no equal sign here. So that gives us 20 minus 20. That's a 16 minus 8 minus 8. So that gives us 0 over 0. And again, that's an indeterminate form, 0 over 0. So that means by factoring up here, we remove the x minus 4. So the h of x is equal to 5 over x plus 2 when I simplified it. But we removed the x equals 4. So x minus 4 is equal to 0. X is equal to 4. So the h of 4 equals 5 over 4 plus 2. So that gives us 5 over 6. So that means we have the point 4 gives us 5 over 6 is a hole in the graph. It's a hole in the h of x. So that's a removable. So we removed the x minus 4. So this is a removable. That's a removable discontinuity. If I can spell it out correctly. Because it canceled out, I was able to find where the hole was. But notice now, I have it simplified to the h of x is equal to 5 over x plus 2. So notice that if x plus 2 equals 0, that means x equals negative 2. So the h of negative 2 is 5 over negative 2 plus 2. That's 5 over 0, and that's undefined. So if it's undefined, that means it has a discontinuity at x equals 2. So notice that discontinuity is an asymptotic, S-Y-M-P-T-O-T. So this is an asymptotic discontinuity. Okay. It's an asymptotic discontinuity. Put all my eyes in there. Because it has notice that we have a vertical asymptote at x equals negative 2. So it's an asymptotic discontinuity at x equals negative 2. So it has two types of discontinuity. One is at x equals 4. One is at the point 4, 5 over 6 removable. And it's asymptotic at x equals negative 2. Discontinuous. So there's one question here giving us two types of discontinuity. And again, this brings us to the end of our video. Again, if you like, you click the like button if you like my video, and the subscribe button if you want to subscribe to my channel. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.